minus q. As it is at center of cavity, so it will be uniform. So I'll put a minus q charge. And what it will do, it will induce charge, this one. See, all these are actually not concepts. Huh? These are some relevant data related to conductors, which in our books not there. They have put it in the form only in the numericals it's available. But actually what happened, a good textbook should have described all the points. It should have been nice. So student would have read and you would have applied. They didn't discuss anything. Net field inside the conductor due to static charges must be 0. Finish over. That is the only point one they have placed it. Remaining all we have numericals here. But you take a electrodynamics, I don't know. He has really worked out a lot. Conductors, what are the conditions needed, everything. So what should be the charge? It should be Q only, plus Q. Uniform or non-uniform? Uniform charge distribution. Okay, tell me now, what will the field? I think it's similar to previous problem what I discussed, no? It is similar to previous problem what I discussed. So therefore now, how I can show field lines? Same earlier, the field lines I'll show by color. So it is similar to charged conductor. So therefore, what is the potential at point P? Shall we directly write the answer? Potential at point P is equal to potential at point P equal to K Q by R. Now you display this cavity. You change the position of cavity. Still what will happen? Still what will happen? The field outside the lines of force, anything will change, magnitude or the charge on outer surface, will it change? No. Irrespective of position of cavity means don't bring outside. Anywhere inside the copper sphere, you displace the cavity. The charge distribution on outer surface will not change. The lines of force will not get disturbed. So therefore, what is the conclusion now? The position of cavity, account or convenient, we can place it wherever we want. That's what happens in numericals. Here is what I'm introducing that particular thing. Okay, next in second case, there's a first case, no? Now come for second case. So the point charge is not at center of cavity. Then charge will be induced. So it will be minus charge. More negative charge will be induced here. Less charge. Minus Q charge. Again, charge on outer surface. Charge on outer surface should be uniform. Okay, again the same lines of force. I'll draw it. Okay, so again, what is the expression for potential here? The same equation, I'll write it, no? Okay, for this, the third case. Now, what about the charge distribution? Definitely will be non-uniform. You can see the cavity. Here I'll show more. And again on outer surface will be uniform. So the field lines similar to conducting sphere. So what is the potential at point P? Again, it is equal to KQ by R. So shall I put in, if you really might have seen, potential due to, in second case again, it's how the outer surface will behave. Outer surface will behave similar to what, like similar to the charged conducting sphere, no? The lines of force are similar to that one. So what is the potential on surface of conducting sphere? KQ by R, the same formula. Even the third case also. I'm not bothered about that cavity inside that one. So even for that, anybody, sir, why you are writing equation and you're not giving any very good reason also. Somehow you are telling charge distribution is similar to conducting charge sphere. I'm using Faraday's cage, that's all here. So what is actually the effect of cavity on outer surface will not be there. Similarly, the effect of charge on outer surface will not have any influence on inside the cavity. That's all. It's either way, vice versa. External charge will not have influence anything on inside the cavity. Similarly, the charges system inside the cavity will not have any influence on external charge system. But sir, I'll make it Q, I'll make it 2Q. As the induced charge, due to that, it will change. But what all you are calculating field, no? So directly what happened, you have to apply the, it is uniform charge distribution. So it is similar to like a conducting charged sphere. So what is the electric field? KQ by R square. So you apply that one, at infinity will be 0. So apply the concept. It is similar to uniform charged conducting sphere. So therefore, what is the potential on the surface? KQ by R. So this will be really troublesome because we don't have any firm formula here. The basic concepts is what we are applying it here. Shall I proceed down? So the position of point charge inside the cavity, the shape of cavity will not determine or will not have any influence on the distribution of charge on outer surface. Long back in the beginning only we have made that clear, no? That only I'm applying here. And how is the outer